This is question 1 of assignment 11, which deals with frequency distribution. So we have to construct a frequency table of the marks scored out of 80. Now I can see that 20 is the lowest mark that has been scored. So I'm going to start my class interval from 20. So let's see. It also says that the class intervals should be of width 10 units each. So that makes it simple. My first is 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, and 70 to 80. Since the maximum marks is 80, I don't need to go beyond that. So So I completed the tally mark part. So let me just add up to get the frequency. So 20 to 30, I have 7 observation, 30 to 40, 8, 40 to 59 observation. In the class 50 to 60, we have 10 observations, 60 to 70, 6 observations, and 70 to 80, 2 observations. So this is the frequency distribution. This is class and this is frequency, right? So bit A is done. Bit B says construct a histogram for the table. That can be done over here. Remember, in a histogram, both the x-axis and the y-axis present quantities. Okay. Once again, please assume that it's a straight line. Right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, where the first one is origin is 0, 10, 20, 30, 40, 50, and so on. This is the x-axis where you have, remember to always label the axis. So it's x-axis where I have marks. Remember, when you make a graph, label the x and the y-axis. So on the x-axis I've got marks, which is out of 80, and on the y-axis I have got frequency. Okay, so 20 to 30, the frequency is 7. 30 to 40, it's 8. 40 to 50 is 9. 50 to 60 is 10. Pretty well behaved histogram that we have. 60 to 70 is 6. 70 to 80 is 2. So that's what the histogram will look like. The next question asks you to plot the frequency polygon. Remember, the frequency polygon is plotted by connecting the midpoints of, okay, let me just take another color. So that's the midpoints of each bar of the histogram, right? And generally what is done is you join it to the x-axis or to the baseline, on the left to the class interval before, and on the right to the class interval after the 70 to 80, the last class interval. So join these with the straight lines. Okay, please draw with a scale so that these are straight lines. So let me see if I can make this better. Once again, right? So the green colored line is your frequency polygon. Please use a ruler and pencil for all these graphs. Remember that in some questions you might be asked to plot just the frequency polygon, or you might not have the histogram given to you. In that case, remember that the frequency should be plotted against the class midpoint. The class midpoint would be the upper limit plus lower limit divided by 2 in the case of each class. So which means in the first case 20 plus 30 by 2 would give you 25. So if the histogram is not given and you're directly plotting the frequency polygon, against 25 you're going to mark 7. Against 25 on the x-axis, mark 7. Similarly, against 35 on the x-axis, mark 8. Against 45 on the x-axis, mark 9, and so on. Bit C asks you to, bit D asks you to construct the less than ogive. The less than ogive, to plot it on the graph, you have to calculate the cumulative frequency. So here I have rewritten the class intervals and the corresponding frequency. So the cumulative frequency, remember, for the first class the cumulative frequency would be 7. For the second class, 30 to 40, the cumulative frequency would be the sum of the first two classes together. So that is 7 plus 8 is 15. For 40 to 50, the cumulative frequency would be 15 plus 9. So that's 24. Basically, I'm adding up all the three frequencies so that I get number of observations less than 50. For the class 50 to 60, cumulative frequency gives you number of observations less than 60, which would mean 24 plus 10, 34. Number of observations less than 70 is 34 plus 6, which is 40, and number of observations less than 80 is 42. Now to construct the less than ogive, you need to plot the cumulative frequencies. Remember, less than ogive means you calculate cumulative frequencies such that each value tells you the number of observations less than the upper limit of the corresponding class. So, since it's a less than ogive, you will plot the cumulative frequencies against the upper limit of each class interval. So less than 30, the number of observations is 7. So against 30, I'm going to plot 7. Against upper limit 40, I'm going to plot 15. Against 50, that is number of observations less than 50 is 24. So that will be somewhere here. Number of observations less than 60 is 34. So that's here. Number of observations less than 70 is 40. And number of observations less than 80 is 42. So somewhere over here. And you can always join the less than ogive to the baseline or to 0 at 20. So remember to use a scale and pencil so that you have joining these points through straight lines. So this is your less than ogive for the given data. Now let's proceed to solve bit E, which is to construct and plot a greater than ogive to show how many students passed the exam. Remember, in the previous question, we know that 50 is the pass mark. So the number of students who pass the exams are those number of observations which are greater than 50 marks. Once again, I have written down the class intervals 20 to 30 going on till 70 to 80, and this is the frequencies that we got when we constructed the frequency distribution table. Remember, we have to plot the greater than ogive curve, and if you want to know the number of observations greater than a certain number, you need to calculate the cumulative frequency from below. That is, number of observations greater than 70 is 2. The number of observations greater than 60 is 2 plus 6, which is 8. The number of observations greater than 50 is 8 plus 10, which is 18. So what I'm doing is, when I want to find the number of observations greater than a certain lower limit, I will add up all the three frequencies from below, starting from below. And so I'm calculating the cumulative frequency from the bottom of the table, or from the highest class interval to the lowest class interval. So proceeding in this way, number of observations greater than 40 would be 18 plus 9, which is 27. Number of observations greater than 30 is 27 plus 8, 35. And number of observations greater than 20 is 35 plus 7, which is 42. Once again, I need to plot this. So that's 10, 20, 30, 40, 50, 60, 70, 100. Remember to keep them spaced equally. $70, $80, $90. Label the axis, and it is always okay. That's x-axis. 1 second. Right. So this is your x-axis, and in the x-axis you are plotting the marks out of 80, and in your y-axis you have the cumulative frequency. So that's cumulative frequency, and we are going 5, 10, 15, 20, 25, 30, 35, 40, 45. So plotting, since this is the greater than ogive and you want to plot it, remember you will plot each of these values against the lower limits. That is, number of observations greater than 20 is 42. So against 20, that is the lower limit, I'll plot 42. Greater than 30 is 35. Greater than 40 is 27, around here approximately. Greater than 50 is 18. Greater than 60 is 8. And greater than 70 is 2. So around here. And join it using a scale and a pencil, that is straight lines. You can always join it to the baseline at right. So this is the greater than ogive. And to find the number of students who passed, we need to find out how many students got marks more than 50. So greater than 40, greater than 50 is 18. So this is also evident from the cumulative frequency table that number of students who got greater than 50 are 18. So 18 students Our next question asks us is bit F, which asks us to find out how many students got first class. And the rules are that those who score more than or greater than 70% are awarded first class. So, if I'm to do that, So, to find how many who all got greater than 70%, it is obvious that I have to use the greater than ogive curve. So, I need to use the greater than ogive. And what is the point at which I need to plot? Well, find out what 70% of 80 is, and that, if you notice, is so all those who get marks greater than 56 are being awarded first class. Now all you need to do is check the greater than curve and see how many people got more than 56. So greater than 56, 56 would fall somewhere over here. Remember, we need straight lines. Okay, not at all straight. Can I just 56? Yep, almost. So that's somewhere around 12 to 13. Once again, it's a little more easy to be accurate if you're using a ruler and pencil. Okay, in questions like this, I would probably give you marks for 12 or 13, either way. So using the ogive curve. Remember to show the plotting of that point greater than 56 on the graph. And we can say that 12 students out of 42 students got first class. The last bit asks us how many students got awarded second class, and those who got 60 to 70% are the ones that are awarded second class. So let's have a look at what second class marks would be. We know that 70 would correspond to 70% would be 56 marks out of 80, and let's see what 60% of 80 is. So it's 48 marks. So all those who got marks between 48 and 56 are the ones who've got second class. Now, to find the number of students falling in the 48 to 56 range, you can use either of the ogives. You can use either the greater than ogive or the less than ogive. So let me show you using the greater than ogive. Now we know that those who got greater than 70% or greater than 56 are 12%, and to have a look at who all got less than or greater than 48, which would be around here. So let's say around 22 people, which means number of students with marks greater than 56 is 12. Number of students with marks greater than 48 is 22. So number of students with marks in the 48 to 56 range is 22 minus 12, which is 10, because we know that 22 students got more than 48, so they have got either first class or second class. So from this 22, if you reduce those who have got first class, you will get the number of students who have got second class, which is 10. Now remember, in the question itself it is mentioned approximately. There might be slight differences depending on how well you have plotted the line, right? So slight differences are allowed. The approximate range in this case is, as number of students in this case, is 10.